The life of Isaac Newton, the man who discovered gravity. Welcome back to our channel. Today, we're exploring the life and legacy of Sir Isaac Newton, a towering figure in the world of science whose discoveries transformed our understanding of the universe. Best known for formulating the laws of motion and universal gravitation, Newton laid the groundwork for classical mechanics and mathematics. His work not only changed the course of physics, but also influenced countless fields, from astronomy to engineering. So, who was Isaac Newton, and how did he come to be known as the man who discovered gravity? Let's dive into his remarkable journey. Isaac Newton was born on January 4, 1643, in Woolsthorpe, England. Tragically, his father passed away just 3 months before his birth, leaving young Isaac to be raised by his mother and grandmother. His early life was marked by challenges. His mother remarried when he was 3, leaving him in the care of his grandmother while she moved away. This separation had a profound impact on him, instilling a sense of independence, but also a longing for familial connection. Despite these hardships, Newton showed an early interest in mechanics and mathematics. He attended the King's School in Grantham, where he excelled academically. In 1661, he enrolled at Trinity College, Cambridge, where he studied the works of great thinkers like Euclid, Descartes, and Galileo. It was here that Newton's intellectual prowess began to shine, setting the stage for his future contributions to science. Newton's education continued until 1665, when the Great Plague forced Cambridge to close temporarily. During this time away from formal education, he returned to Woolsthorpe and began to explore his own ideas, an experience that would prove pivotal for his scientific development. During this period of isolation, often referred to as Newton's Annus Mirabilis, or Year of Wonders, he developed many foundational concepts that would later define his work. He famously recounted that it was during this time that he saw an apple fall from a tree, prompting him to contemplate why objects fall straight down rather than sideways or upward. This moment inspired his thoughts on gravity and led him to formulate his theory of universal gravitation. In 1666, Newton returned to Cambridge and began working on what would become his groundbreaking publication, Philosophiae Naturalis Principia Mathematica, commonly known as the Principia. Published in 1687, this work introduced his 3 laws of motion and laid out the law of universal gravitation. Newton's 3 laws of motion revolutionized our understanding of physics. First law, law of inertia. An object at rest stays at rest, and an object in motion continues in motion with the same speed and in the same direction unless acted upon by an external force. This law explains why a stationary ball won't move until kicked, or why a rolling ball eventually stops due to friction. Second law, F equals ma. The force acting on an object is equal to the mass of that object multiplied by its acceleration. This means that heavier objects require more force to move them compared to lighter ones, a principle that helps us understand everything from car crashes to rocket launches. Third law, action-reaction. For every action, there is an equal and opposite reaction. This can be observed when you jump off a small boat. As you push down on the boat to propel yourself upward, the boat moves backward. Newton's laws of motion not only revolutionized the field of physics, but also had far-reaching implications for various aspects of society. They influenced engineering practices, enabling the design of safer and more efficient machines, vehicles, and structures. For instance, understanding these laws allowed engineers to build bridges that could withstand heavy loads and to develop safer transportation systems. Furthermore, Newton's principles laid the groundwork for advancements in fields like astronomy, where they helped scientists predict celestial events and understand planetary motion. This shift in thinking encouraged a more scientific approach to problem-solving across disciplines. ultimately fostering the spirit of innovation that characterizes the Enlightenment era. Newton's law of universal gravitation states that every particle attracts every other particle in the universe with a force proportional to their masses and inversely proportional to the square distance between them. This groundbreaking idea explained why planets orbit the Sun and how objects fall toward Earth. Newton's work effectively unified terrestrial and celestial mechanics under one set of principles, an idea that had profound implications for astronomy and physics alike. His simple yet powerful equation helped overthrow centuries of Aristotelian thinking about motion and laid the groundwork for future scientific exploration. In addition to his work on gravity and motion, Newton made significant contributions in optics. He conducted experiments with prisms that revealed white light is composed of various colors, a discovery that challenged existing theories about light at the time. His findings were published in his book Optics in 1704. Furthermore, Newton developed calculus independently around the same time as German mathematician Gottfried Wilhelm Leibniz. Their simultaneous discoveries led to a bitter dispute over who invented calculus first, a debate that lasted for years but ultimately established calculus as an essential tool in mathematics. In later years, Newton transitioned from academia to public service. He became warden and then Master of the Royal Mint in London, where he implemented significant reforms that improved currency management and helped combat counterfeiting. Newton also served as president of the Royal Society from 1703 until his death in 1727. Despite his success, he was known for being somewhat reclusive and often engaged in disputes with other scientists like Robert Hooke over credit for discoveries. Isaac Newton passed away on March 31, 1727, at the age of 84. He was buried in Westminster Abbey, a testament to his immense contributions to science and society. Newton's influence extends far beyond his own time. His laws continue to underpin much of modern physics today. His work laid the foundation for classical mechanics and has shaped our understanding of everything from engineering principles to space exploration. His legacy also serves as an inspiration for countless scientists who followed him, reminding us all that curiosity about the natural world can lead to groundbreaking discoveries. In conclusion, Isaac Newton was not just a brilliant scientist, he was a transformative figure whose ideas changed how we perceive our universe. From formulating laws of motion to uncovering the principles governing gravity, Newton's contributions have left an indelible mark on science. Thank you for joining us today. If you enjoyed this video or have any thoughts, please leave a comment below. Don't forget to like and subscribe for more. Let's continue exploring together.